Welcome to 11.2 Prisms. Okay, so you already know how to find the volume of a prism. Okay, well, you have to find the area of the base and then you multiply that times the height. Now, Cavalieri's principle is for two solids. Okay, for any two solids, if all planes are parallel to a fixed plane, form sections having equal area, then the solids have the same volume. So let me just show you a picture of what Cavalieri's principle represents. Okay, so here are two rectangular prisms. Now, the one on the left is a right rectangular prism. It stands upright. The angles are all right angles. But the one on the right, if you look over here, is an oblique prism. So I want to take cross sections, and I'll give you an official definition of cross section in just a minute. But these are sections that if I think of them as slices, I take parallel slices to the base, then they are exactly the same area as the base. So all of these these three here, there's four, are exactly the same area as the base. These are called cross sections, and they're parallel planes to the base. A cross section of a prism is congruent to the base of the prism. So that's the official definition of cross section. Okay, so a cross section is the intersection of a three-dimensional figure and a plane that passes through the figure that is perpendicular to the altitude. Now, we haven't talked about altitude in a while, but it is a synonym to height. Okay, so the theorem 11.2 refers to cross sections that are parallel to bases, but let's talk about what an altitude is. So here is a plane that is parallel to both of these prisms' bases. If you notice, let's look at the prism, the rectangular prism, that's the one on the right-hand side of the screen. Notice that it's right through the center, at least it looks like it's a bisector. We can't really tell for certain, but it is another rectangle, which is the same as the base. Now, if you look at the one on the left, this is not a rectangular prism. This has 5 sides, so this is a pentagonal base prism, even though it's not a regular pentagon. The cross section is still the same as the base, same area, but if you look, we have to draw a perpendicular line from the top of the prism down to where the base is, and to make that right angle, that's called an altitude. So just a reminder, the volume of a prism is the product, which means we're multiplying, of the height and the area of the base. So here's where things get a little bit trickier. Like when you're making your card for this chapter test, you are going to need to do some translating for your formulas, because right now the big B, the capital B, means the area of the base. Little b just means the base length, like of a triangle. When we say half base times height, we're talking about the little b, or just the base of just that little triangle. But big B means area, and then big H means the height of the 3D figure. So let's work through an example. We're going to find the volume of this regular prism. So we have how many sides? 6 sides. That means we have a hexagon, and it's a regular hexagon. They're telling us that in the directions. Okay, so we have a side length, it looks like, of 8, and that's just of the base, and then we have a height of 14 square root 3. So here's a zoomed in base of this prism. So I'm just looking at the base so I can get rid of the other lines. We don't know the apothem of the hexagon, but we do know that one side is 8. So if I drop that apothem down, it's going to be a perpendicular, so I'll have two little right triangles, and that means that I can use the Pythagorean theorem. So So if I'm going to find that apothem, I have a side of 4, and I know that it's 4 because that is exactly a bisector of the side, and then that means this hypotenuse is 8. And I can solve for the other side, which is the apothem. Okay, the apothem is exactly 4 times the square root of 3. And I want to leave it in that form until the very end. I don't do any rounding or any approximating with decimals until the very, very last step. That's really important, or you're going to get different numbers than I get, and you'll get points taken off on a quiz or a test. So after I found the apothem, I can now find the area of the base. That's half apothem times perimeter. And I know the perimeter is 48 because there's 6 sides and each one is 8 in length. So that means the area of the base is 96 square root 3. Okay, so the last step is to find the volume. Now this is a step chart. First find the apothem of the base because we need to know that for the regular polygon. Find the area of the base and then find the volume. Now you might not always need to find the apothem because it may be given or it may not be a regular shape. So it's always find the area of the base and then find the volume. So remember, big B is area of the base, which we decided was 96 square root 3, and the height is 14 square root 3, so we can multiply those together and we will get 4,032 cubic units for this example. The last thing I want to review, this should be reviewed, we did this actually in Algebra 1, is how to find the area of an equilateral triangle when you're not given the height. Maybe you're just given one side. So this is called Heron's formula, so I just need a little reminder. In Heron's formula you need a semiperimeter, and that is 1/2 the perimeter. Okay, so if you add up all the sides and then divide by 2, you have the semiperimeter. So you don't have to have an equilateral triangle. I didn't mean to be misleading there. It can be any triangle that you know all 3 sides. So it can be a scalene, it can be a right, it doesn't matter. If you had a right triangle though, you would still probably do half base times height. But if you don't know the angle measure at all, but you have all 3 sides, you can use Heron's formula. So here it is. It's the area equals the square root of the semiperimeter times the semiperimeter minus the side of A times the semiperimeter minus the side B times the semiperimeter minus side C. Okay, you multiply all those together, then take the square root, and you will have the exact area of a triangle. You're going to need that in the whisk that I'm about to give you. This is also a reminder page of all of the area formulas we learned in Chapter 8. So these will be a base of a prism. So if you have a triangular base, if you have an equilateral triangle base, we have special formulas for all of these things. You know, remember a circular base means it's a cylinder, and the area of a circle is pi r squared. You've got trapezoid, rhombus, anything you need, you're going to need this to find big B in our formulas. For your whisk summary, you have 3 practice problems. They all have to do immediately with finding the volume of prisms. So email me and I will see you in class.